Hi, Algebra 2. This is Unit 4, Lesson 11A. So Lesson 11 was kind of long, so I separated it into two lessons for us. We're going to be solving logarithmic equations in this lesson. There's two different equations we're going to do. So the first one, we're going to have a log equal to a log. So if it's not you need one log on the left, one log on the right. If you don't have one, but you have two on the left, say, they have to be condensed. So we'll look at those. Then I use the one-to-one property. So basically, if I have log base b of m equals log base b of n, notice these bases are the same. Then all you have to do is set m equal to n. So if you have one log on the left and one log on the right, and they both have the same base, then you can just set m equal to n. So I have to basically get one log on the left and one log on the right. And then I have to solve and check for extraneous solutions. So just quickly plug back your answer and make sure that you're not going to have the log of a negative number. So anyway, let's see what we have. We have log base 5 on the left. I have log base 5 on the right. So I have the same exact base, and I have one log on the left, and I have one log on the right. So I'm just going to take the 5x plus 9 and set it equal to the 6x. Right, so this was a nice easy one. I subtract 5x, and I get x equals 9. Quickly in my head, I'm going to plug in 9 on the left and the right, and just make sure that it will not result in a negative number. You cannot take the log of a negative number. All right, so here I have log base 2 of 1 minus 4n and log base 2 of 2n plus 43. Perfect. So I have log base 2. I only have one log on the left, one log on the right. So I'm just going to take these and set them equal to each other. 1 minus 4n equals 2n plus 43. So I'm going to add 4n, and I'll get 6n. And I'm going to subtract 43, and I'll get negative 42. So n equals negative 7. Now quickly plug in. Negative 4 times negative 7 is positive 28, so that's okay. 2 times negative 7 is negative 14 plus 43 will still be a positive, so it's okay. All right, 3. So I have log base 9 on the left, log base 9 on the right. So perfect, I just have one log on each side. 6 minus 3w equals negative 2w. And I'm going to add 3w, and that gives me w on this side equals 6. But when I plug in 6, negative 3 times 6 is negative 18, and 6 minus 18, no solution. Again, 6 minus 3 times 6 is 6 minus 18 is negative 12. So this is not a solution. You cannot have, there's no solution because the solution I got makes it negative. All right, it cannot be negative. All right, so the problem with number 4, it's going to be log base 10, but look how I have two logs on the left. So I'm going to have to condense those together. So when I am adding, I'm going to condense them together through multiplication. So I'm going to have log base y plus 5 times 4. All right, I'm condensing those two logs since they have the same base together. When I condense them, there'll be multiplication. Now this 4 needs to be multiplied by the y and by the 5. All right, so that's going to be 4y plus 20. And this side was absolutely perfect. It's just going to be equals 72. Okay, maybe I'll write that so it makes a little bit more sense. So now I'm down to, look how I have one log on the left, one log on the right. They have the same base. It's base 10. So I'm just setting these equal to each other and solving. So I subtract 20, 4y equals 52. Divide by 4, y is 13. Quickly plug in the 13 just to make sure I don't get any negatives, and I do not. All right, so getting a little bit more complicated here. The right side is perfectly fine because I just have log of 7. The left side is not perfectly fine because I have that 3 in front. So what I'm going to do is I'm going to make it log base 7 of 4 to the third power. So I'm taking this and I'm putting it into the exponent over there. Now it's perfect in that I have log base 7, and on the right I have log base 7. Once I have just one log on the left, one log on the right, then I can set these equal to each other. 4 to the third is just 64. And then I can solve. I add 8, divide by 4, a is 18. Quickly just plug in 18 to make sure that you will not get any negatives, and you will not. All right, so looking a little bit more complicated here, I got 2 logs on the left. They are subtraction, so I'm going to combine them together. I'm going to condense them, and when I do that, I will be dividing them. Okay, so this is what we worked on yesterday, the whole reason behind what we did yesterday. So I need to condense these together. There's subtraction. When I condense them, I'll be dividing. 68 divided by 4 is 17. As soon as I have one log on the left and one log on the right, and they have the same base, which they do, then I'm just going to combine. I'm going to set equal to each other. 17 equals 3n plus 11. I sort of drop the logs. Subtract 11 and I get 6. Divide by 3 and I get 2. Quickly plug in 2 just to make sure it does not give you any negatives, and it will not. And same thing here. I have this 1/2 in front, so I'm going to make this log base 6 of 25 to the 1/2. And log base 6 of 23 minus 4w. So I have a log on the left, a log on the right. They have the same base. 25 to the 1/2 is really just a square root of 25, which is 5. And then I will, let's see what I want to do, subtract 23. And I'll divide by -4. W equals 9 over 2. So I am solving some logarithmic equations. Left side looks fine. I have log base 3 of 2p minus 5. Right side does not look fine. I got a bit of a mess there that I have to condense together because I need a single log on the left and a single log on the right. So I am going to take this 2 and I am going to make it an exponent for the 6. And I want to condense these together. They are subtractions, so when I condense them together, they have the same base. I'm going to divide them. 6 squared is 36, divided by 4. And I finally have a single log on the left, a single log on the right, just to show you. So then I'm going to drop the logs, and I will set 2p minus 5 equal to 36 divided by 4 is 9. And quickly just plug in 7 to make sure that it's not resulting in a negative number, and it is not. All right. I do want to do 9, okay, because that's an important one, because I'm going to wind up factoring on number 9. All right, so number 9, I have log base 4 of m squared, and that's perfect. And on the right, I have log base 4 of 18 minus 7m. So I got one log on the left, one log on the right. They're the same base, so I'm just going to set m squared equal to 18 minus 7m. I'm going to bring the 7m over to the left, and it'll become positive 7m, and I'm going to bring the 18 over to the left, and it'll become negative 18. All right, why did I do that? Because I have an m squared. The way to solve a quadratic, everything comes on one side, and then I factor it. All right, m times m is m squared. I'm saying what numbers multiply to 18 and add up to 7, and that would be a positive 9 and a negative 2. And then I set each of these equal to 0 and solve. So I get 2 answers. And I just want to quickly plug them both back in for m, just to make sure it does not result in a negative. So negative 9, that's the one I'm more concerned about. Negative 9, but I'm squaring that, so it's 81. And over here, negative 7 times negative 9 is positive 63, so we're all set. And when I plug in 2, 2 squared is 4, and 18 minus 7 times 2, 18 minus 14 is 4. It's still okay. So both of these are perfect. Okay, let's try some of the logarithmic equations. This is the second kind where I'm just going to have a log equal to a number. Basically, what you're going to do if you have to condense anything and isolate the log, we will do that. But we're going to put this back into exponential form, and then we're going to solve and check for any extraneous solutions. So again, I got a log, only one log on the left, perfect. I'm going to take this and put this back into exponential form. So this is going to be 2 to the 6 equals x minus 4. 2 to the 6 is 64. You can do that in your calculator. And I solve for x. X is 68. Plug in 68 just to make sure it's not a negative number, and it's not, so we're perfect. Okay. For this one, I just want to have one log on the one side and I want a number on the other side. So I'm going to take this 7 and move it over. So I have log base 3 of 4x plus 8 equals 4. And now, since I have a log equal to a number, I'm going to put that back into exponential form. 3 to the 4th equals 4x plus 8. 3 to the 4th is 3 times 3 times 3 times 3. And I'm just solving this. I'm going to subtract 8. I'm going to divide by 4, and I do not get a whole number, so I'm just going to leave this as 73 over 4. All right, so on 13, I will have to condense and isolate that logarithm because I got two logs going on. They are base 10. All right, so I can put that 10 in if it's going to help us out. So I'm adding them. So that means I am going to wind up multiplying these. 2x times x minus 5. Okay, 2x times x minus 5 is really 2x squared minus 10x. And now I'm going to put this back into exponential form. So this is 10 to the second power equals 2x squared minus 10x. This is going to be another factoring one. 10 squared is 100. I'm going to run out of room here. I need everything on one side. I'm going to move everything to the right because I don't ever want to have that x squared being negative. Okay, but I can factor out a 2. The first step in solving is to factor out a greatest common factor if there is one. And there's a 2. And I'm going to run out of room, so maybe I'll write it over here. I'm looking for the numbers that multiply to 50 and add up to 5. So that's going to be 10 and 5, right? Negative, and it needs to be a negative 5, so it's going to be negative 10 and positive 5. So basically my answer are x equals 10 and x equals negative 5. Now when I plug in 10, 10's fine. But when I plug in negative 5, 2 times negative 5 is negative 10. You are not allowed to have the log of a negative number, so that's an extraneous solution. It's a solution that's not going to work. All right, 14 also does not have a base, so it's going to be base 10. Log base 10 of x. I'm going to put this 2 back up there, and I'm subtracting them. I need to combine these together into one log. I need one log on the left. So that's going to be x squared divided by 4. Okay, I put it back into an exponential form. 10 squared equals x squared over 4. 100 equals x squared over 4. Put a 1 under here and cross multiply. X squared equals 400. So x equals 20 and x equals negative 20. But negative 20 is an extraneous solution because I can't have the log of a negative number. All right. Again, I got two logs, so I'm going to have to simplify them, condense them. So log base 6, and this is addition. So when I condense them together, I will be multiplying them. So that's going to be x plus 9 times x. So that's really log base 6 of x squared plus nx. And I'm going to put it back into exponential form now. Oops. So this is going to be 6 squared equals x squared plus 9x. 36 equals x squared plus 9x. Again, it's an exponential. It's a quadratic rather, so 0 equals x squared plus 96. That's not 96, 9x. Minus 36, because I brought that 36 over, and now I'm factoring it. What numbers multiply to 36? Add up to 9. Well, that's going to be a positive 12 and a negative 3. And then I set each one equal to 0, and I get two solutions. And I'm just going to plug them both back in to see what works. Negative 12 plus 9, not going to work. All right, because that will give me a negative as an answer. All right, and this last one right here, again, I have two logs, so they're base 10. I'm going to condense them together. So it's going to be x minus 3 times x, because there's addition right there. So when I combine them together, when I condense them, there'll be multiplication. So this is going to be log base 10 of x squared minus 3x. And then I'm going to put it back into exponential form. 10 to the 1 equals x squared minus 3x. 10 equals x squared minus 3x. 0 equals x squared minus 3x minus 10. I'm factoring them. What numbers multiply to 10 and combine together to give me a negative 5? That would be a negative 5 and a positive 2. Quickly just plug in. 5 minus 3, that's good. Negative 2 minus 3, not good, because you cannot have the log of a negative number. All right, so we did a lot today. We did two types of equations. One where I just had a log equal